Alright, we're going to try this. F of x equals x squared plus 3. We'll make it 2x squared plus 3 at the point 1, 5. And so we are using the first definition of the limit. Limit is delta x approaches 0 of f of c plus delta x minus f of c, where this is c and this is f of c. So when I plug in my numbers, I start out with f of 2 parenthesis 1 plus delta x squared plus 3 minus 5, because that's f of c divided by delta x. And this squared should be on the outside. So when I do 1 plus delta x squared, that's 1 plus 2 delta x plus delta x squared when it gets multiplied out, and I need to multiply that by 2. So now I have 2 plus 4 delta x plus 2 delta x squared plus 3, not minus 3, minus 5 over delta x. The 2 plus the 3 minus the 5 is 0, and we are left with 4 delta x plus 2 delta x squared divided by delta x. Now, delta x cancels from each one of these, and we get 4 plus 2 delta x. Now, of course, the limit as delta x approaches 0 means that this whole thing becomes 0, and my answer for the derivative, so the slope of the tangent line, will be 4 right there. For this next problem, we're going to do the second definition, where they don't give us a point, where we just find the derivative at any point. And we'll do the fraction one first, and then next we'll do the root. So I got 2 over x plus delta x, because everywhere I see an x, I put a x plus delta x, minus 2 over x divided by delta x. Limit as delta x approaches 0. So I'm going to use the old-fashioned, how do you get a common denominator? You cross multiply, so 2x minus 2 times x plus delta x over x plus delta x times x, all still divided by delta x. Now, of course, when I distribute the 2 on the top, I get minus 2 minus 2x minus 2 delta x, and these two things can cancel. So I have negative 2 delta x over x plus delta x times x times the derivative, dividing delta x is the same thing as multiplying by the reciprocal, which is 1 over x, and these delta x's can disappear. So I wind up with negative 2 over x plus delta x times x, but the delta x becomes a big old 0, and so x times x becomes negative 2 over x squared, and that's my derivative for any x value that exists. For my next example, same rule, but I'm going to do 2 square roots of x. So I got the limit as delta x approaches 0, 2 square root of x plus delta x minus 2 square root of x divided by delta x. Now, in order to do this, I want to rationalize the top. So that's 2 square root of x plus delta x plus 2 square root of x divided by delta x. No, not that. Divided by the same thing. So when I multiply the top, because I know the middle two terms will cancel out when I rationalize, I get 4 times x plus delta x minus 4x over delta x times 2 square roots of x plus delta x plus 2 square root of x. Now when I distribute, that's 4x plus 4 delta x, and this 4x and that 4x will cancel each other out. So I now have 4 delta x over delta x times 2 square roots of x plus delta x plus 2 square roots of x. Delta x and delta x cancel, and after that, the limit as x approaches 0, delta x approaches 0 means I have that. So I have 4 over 2 square roots of x plus 2 square roots of x. 2 square roots of x plus 2 square roots of x is 4 square roots of x. The two 4's can disappear, and I'm left with 1 over the square root of x. Alright, the last problem for this one has our last definition of the derivative, which is the limit as x approaches c of f of x minus f of c for the change in y over x minus c for the change in x, where this is c and that's f of c. So the limit as x approaches c of f of x, well, that's going to be x to the 1/3 minus 0 over x minus 0, because the f of c is on top and the c is on the bottom. So when I subtracting 0 doesn't change anything, and when I divide monomials, I subtract the exponents. The bigger one is in the denominator, so I'm going to make this 1 minus 1/3, which is 2/3, limit as x approaches c, which is 0 this time, so I should have put 0 right here as well. Which means I got 1 over 0 to the 2/3, which means that the derivative in this case does not exist, because we can't do 1 divided by 0.